Hello. Today we will be going over the omniphysical knowledge graph. In this project, we have leveraged AI to extract key information from various personal documents that a person would have compiled during their lifetime. So the personal documents can be of any variety. It could be their own autobiography, it could be details about their family members, it could be the vacations that they took, the work details, anything. We use AI to extract all the key information from all of those documents from all of the years that they have stored, and then we retrieve them accurately. And we do this using a knowledge graph, which is plotted in Neo4j, and retrieving it via using GraphRAG approaches using OpenAI GPT models. And let's take a look at how this works. So let's get into the application. So when we load in, we have our main application, which is a chatbot. So we can ask any question that we want to, and it will retrieve the knowledge graph information, which has been created based on all of the documents that it was passed, and then it will accurately give you the responses. And we also have a KGQA evaluation page. So this is just for testing, like how accurate is our knowledge graph. So based on the documents that we have currently processed, we can select like any one of them, and we can also choose the number of chunks that we want to process, because obviously the bigger the documents, the more chunks and the more it would cost. So that's why we have given the user this option to choose how many chunks that they want to test on. So first, let's go over to the Q&A one, and let's ask some questions based on the data that we have. Who is John Gallivan Hilly? So basically right now in our database, we have all the documents of a person named John Hilly, their family, their work details, and like their whole history. And based on that, we have created a knowledge graph which stores this information accurately and gives us like the answers based on that. So here, John Gallivan Hilly is a young member of the Hilly family. He's the grandson of John Hilly, and so on. So we can also ask like more specific questions, more analytical type of questions, or whatever we want to. For instance, like who is Chinook? So Chinook is basically one of the two lovely dogs that John Gallivan Hilly uh, loves and used to play with. So we can just ask something like that and accurately get the responses. Like Chinook is a neighborhood dog owned by Joel Namian. He's described as one of the two very sweet dogs down the street. So this is how we can store like all of the information about a person's history and retrieve them whenever we want to. Now let's go over to the QA evaluation loop. So let's say we want to evaluate the QA from this talk. So QA just stands for question and answer. So what's going to happen here when we run the evaluation is that one AI agent will generate questions based on the chunks that this document has. So currently it's on chunk 1. It will make a question based on that. And then the same question is given to our knowledge graph agent, which does not have the access to the source chunk. It only has access to the knowledge graph that we have created, and it needs to answer using the knowledge graph only. And then based on the expected answer from the chunk 1, we will then evaluate whether the knowledge graph extraction worked correctly or not. And while this is going on, let's go over and take a look at how the information is actually stored in Neo4j. So this is the AuraDB instance for database. And as you can see, we have over 5,300 different nodes, over 11,000 relationships, some properties, and so on. So let's just take a look at one of the documents. So this is a document hilly 2018.docs. We can expand it, And then we will get all of the different chunks or the paragraphs that are attached to this document. So this is the first chunk. When we click the first chunk, we have its ID, chunk index, and so on, all the different properties, and the source text. So what was the actual information that is actually stored in this document is stored here for provenance. And similarly, it is done for every single paragraph. Now, when we expand uh, this first paragraph, we will see now we have a lot more to view. So what's happening here is that all of the entities present inside of this chunk have been extracted. For instance, Chinook that we just looked at was first mentioned in this chunk. And this entity will have an edge saying mentioned in, which goes to wherever it was mentioned in whichever chunk. And then we can expand Chinook and see the connections for Chinook as well. So this is John Gallivan Hilly's connections to Chinook. John Gallivan Hilly uh, is related to Chinook because he likes playing with him, loves one of the two very sweet dogs just down the street, and Joel Namian owns the dog. So another relationship for Joel is created with Chinook. So this is how our information is stored in the knowledge graph. And the similar pattern is done for every single document and every single chunk. And yeah, they all have different types of entities. Like this one is for media, this is for person, this is for toys that are mentioned, this is for different types of food. So based on that, we can always ask any type of question like what food did we like as per this document in here, or what did we do during this vacation, uh, and so on. Now let's go back to the UI, and the evaluation is now complete. So we got a 5 out of 5 score for this document, and the score distribution is marked accordingly. So a 5 is a perfect score. Mostly correct gives you 4, partial for 3, wrong is 1, and yeah, related or wrong is 2. So let's see what it does. So for instance, for chunk 0, it went into chunk 0 and then generated this question: at which school did John Gallivan Hilly finish first grade in June? So the expected answer was Naismith, and this is what the AI agent generated. He finished the first grade at Naismith in June. John finished first grade at Naismith, doing exceptionally well. So this is based on whatever was present in the document, and it was a correct answer. That's why it scored 5 out of 5. And similarly, it's done for all of the other chunks as well. And we can download this as a JSON if we want to view it later, or we can just switch the document and you use the QA loop for something else. So yeah, that's how our application uses AI and improves the retrieval over basic RAG applications by incorporating knowledge graphs. Thank you for watching.